Alright everyone, we are ready to begin notes for section 11.3. We'll be talking about circles and how to find the areas of circles, and then the area of what are called sectors, and we'll examine what that is here in just a moment. Alright, now again, if you're confused by any of this, make sure you're looking in your textbook at the lesson 11.3 to go over some of this vocabulary. All this vocab needs to go in your vocab notebook, and that way you're up to date on all the different terms we'll be using. Now, here's what we want to look at. Area of a circle, you guys have seen this before, at least that's my hope. Area formula for a circle is pi times the radius squared. Okay, remember when we talked about circumference of circles in chapter 10, we said cherry pie is delicious. Circumference, C, equals pi times diameter. That's a formula for the circumference. But area of a circle, okay, this two-dimensional measurement, the amount of space that the circle takes up is pi times the radius squared, and we'll still be in square units because of that. Okay, so once again, remember we can write answers in exact form or approximate form with circles because we'll be using pi. And then that moves into talking about what the area of a sector is. Now, a sector is something that was mentioned in chapter 10, but we skipped the lesson that it was covered in, so I'm going to tell you about what that is now. A sector is a portion of a circle formed by two radii making a central angle and the intercepted arc. Okay, so that shaded region is an example of a sector. Okay, a sector is essentially like a slice of pizza or a slice of pie. It's that entire region surrounded in there that's shaded. Okay, now the x that we're using in this formula is the measure of that central angle, or it's the measure of the arc, whichever one you want to think of. And you'll notice this looks a lot like our formula for arc length, but now we are talking about sector area. What I want you to pay attention to is this. We still have pi r squared as part of that, and we're just taking x out of 360. This comes from just the portion of the circle that we're going to be calculating the area of. Okay, so if I have a 90-degree angle here, that's a fourth of that circle, so I'm just going to take a fourth of the total area. So I do 90 out of 360, that would reduce to 1/4, and so that's how I could do that. Okay, a semicircle, if my sector was formed with a semicircle, then it would be 180 out of 360, that's 1/2, so we do half the area. So that's kind of some other examples, but we can use a lot of different angle measures in there to create these different sectors. Okay, so let's look at example 1. We have a swimming pool company manufactures circular covers for above ground pools. Okay, now here's what we know. We have really two circles we're looking at. The pool itself is 18 feet across, but the cover is 1 foot longer than the pool on each side. So we're extending each radius by a foot, but that means we extend our diameter by a total of 2 feet, one here and one here. So the diameter of our cover is 18 plus 2, or 20. And so that's going to be important here in just a minute. So we want to find the area of the cover. Alright, so we are going to use our area formula for a circle, and as I've been telling you guys this chapter, it's really important that you write down the formula and then plug in the pieces that you know. So area formula is A equals pi r squared. Okay, we are calculating to find out what the area is, so there's nothing to plug in for A. Okay, and we're going to take pi times the radius of the cover. Now if the diameter of the cover is 20 feet, then the radius is half of that. So the radius is 10 feet. So I'm going to do 10 and square that. Now as we go to calculate this, you need to remember that we do exponents before we multiply by pi. So you're going to do 10 squared first. Okay, and you'll notice this last sentence of example 1 says to give answers as both exact and rounded to the nearest hundredth. Okay, so we're going to have an exact answer and a rounded answer or approximate answer. Okay, so our exact answer is actually pretty easy because we do everything except multiply by pi. So we're going to do pi times 10 squared. Well, 10 squared is 100, so it's pi times 100, and we just switch places with those. So our exact answer is 100 pi square feet. Okay, but then when I round that to the nearest hundredth, I'm going to multiply these together with the calculator and show 2 decimal places. So when I do 100 times pi, we get 314, and then 2 decimal places is 0.16 square feet. If you have any questions about that, make a little note of them so you can ask me about it in class. All right, let's look at the next couple examples. Example 2, we want to find the radius of a circle when I am given the area. And so once again, I really don't even have to draw the circle. I just need to start with the formula. Area of a circle equals pi r squared. Okay, so once again, we are going to plug in the parts that we know, but this time we know the area is 58 square inches, so that goes in place of the A. And we're trying to solve this equation for r. So we're going to solve this equation and get r all by itself for our final answer. And we will round this answer to the nearest tenth. And so what we need to do first is to get rid of the pi. We want to get r squared by itself first, and to get rid of pi, you need to understand that this is pi times the radius, so we undo that multiplication with division. So we divide by pi. That means we divide the other side by pi. So we're going to do 58 over pi, and I'm going to go ahead and write the long form of what that decimal is. Okay, it's about 18.46197. Okay, just showing you in the calculator. 18.46197, then 34. Okay, you can even write that down if you want. And that is what equals r squared. And the reason I don't want to round it to that nearest tenth in this example is because I'm actually going to use that value in the calculator and take the square root of that number. And I'll show you more about how to use the calculators when we get into class. But to get r squared and turn it into just r, to cancel out r squared, remember that we take the square root of both sides of that equation. And so we're going to do the square root of the answer we just come up with. Okay, so I'm just going to do the square root, and I can pull back the previous answer like that. And so we get about 4.2967, but we are going to round that to the nearest tenth and get 4.3 inches. It's just a radius measurement we found, so it's just inches, not square inches. Okay? All right, I want you to try and do the same thing for part B that we just did. You're going to work through the exact same way, and you'll actually work it through and get what the radius is, but then it says to find the diameter. So once you know what the radius is, okay, you're going to take 2 times that radius to get your diameter for your final answer, and round that to the nearest tenth. Okay? All right, hopefully you've had a chance to start this on your own. If you haven't, go ahead and pause the video if you'd like a little more time. Otherwise, you can click play and see how this is worked out. Okay, we start with our formula. Area equals pi r squared. Okay, the area given to us is 45 square inches, so we put in that for A. Okay, once again, the next step, sorry, let me get out of the glare. Okay, the next step is to divide both sides by pi to cancel that out. So we get that r squared is equal to, it's a number that's about 14.3239. Okay, so we take the square root of those two sides, and we get a radius is about 3.7846987. Okay, you can kind of see what the calculator screen gives you. It's kind of bright. Sorry about that. Okay, and so we're going to take that number that's approximately 3.78, and we're going to double it. I'm actually going to use that whole number, the full long number there, and multiply that by 2. And we get that our diameter then is about 7.6 inches. Okay, so that's what you should get for a diameter. All right, a few more examples here. Now we are going to move on to talking about sectors, and I use the example of a pie. We are given that a pie has a diameter of 9 inches, and we can cut that into 10 congruent slices. Now, I'm going to draw this for you. Okay, I'm going to cut it into 10 congruent slices. Okay, those don't look congruent, but they are 10 slices. Now, if each one of these angles I've created in the middle, Okay, if there are 10 congruent slices, there are 10 of those congruent angles, so they're all equal parts of the full circle. So to find out what one of those angles is, I'm going to take 360 and divide it by 10, because there are 360 degrees, and there are 10 equal angle measures. So 360 divided by 10 is 36. So x is equal to 36 degrees on all of these slices. Every one of these angles is 36 degrees. And it asks, what is the area of one slice? Well, that is a sector. We have two radii forming a central angle and an intercepted arc. That is creating a sector here. So we're going to use our area formula for sector of a circle. Whoops, just about wrote that wrong. There we go. Fix that. Sorry. Make sure you have that correct. That's the area formula for the sector of a circle. And we're going to plug in the things that we know to find the area. I just showed you how to find x. Each of these angles measures 36 degrees, so x is 36. Okay. Times pi times r squared. We need to talk about what the radius of the circle is. The radius is always half of the diameter. If the diameter is 9, the radius is 9/2 or 4.5. Okay, so we're going to take 4.5 and square that and multiply it by pi, and then multiply that by 36 over 360. Now, we can go through standard order of operations to put this in the calculator in the right way. Okay, remember, according to PEMDAS, we do exponents before we do any multiplying. So I'm going to do 4.5 squared first. Okay, then I'm really just going to work backwards. I'm going to hit times pi, then times 36, then divided by 360. Okay, and if I hit enter, the calculator will do the work, and I get an area of that sector of that piece of pie that is approximately 6.36 square inches. Okay, we'll go over some more examples like that in class. All right, so lastly, let's take a look here and find some sector area for each of these shaded sectors. Notice the shaded region here looks more like just a regular slice of pie, but in this one, the shaded region is actually most of the circle. And so when we use x, we're not using the 36 degrees. That would give me this area. I'm going to use everything else, and so we'll come to that one in just a minute. First of all, let's start with the easier one. Okay, x out of 360, x is 88 degrees times pi times the radius of 7.5 squared. Okay, once again, we're going to put that in the calculator in the correct order of operations. We're going to do 7.5 squared first times pi times 88 divided by 360. And we get approximately 43.2, we're rounding to the nearest tenth, so 43.2 square centimeters. Okay, and then lastly, we will do the same thing for this sector. Okay, the radius is 10, but the angle measure I'm using is the shaded region of everything except 36 degrees. So x is actually equal to 360 minus 36, which is 324. So we're going to use 324 over 360. And once again, we'll put that in the calculator like this. Okay, do the 10 squared first, then times pi, then times 324, then divided by 360. And we get approximately 282.7 square meters. Okay, so that's sector area and circle area, and we will do some more of that in class on Monday. So make sure you've got good notes taken. Go back and rewatch anything you need to. Take a look at lesson 11.3 in your book, and we will do more work on Monday. Otherwise, have a good weekend.